All right, so we talked about functions, but how do you evaluate a function? What does it mean to evaluate a function? That's in today's lesson. So what are we looking at? My name is Brandon Clayton, the Algebra Guy, and today our TEK is 12B, evaluating functions. Expressing function notation given one or more elements in the domain. So what does all that mean? What does it look like? It's pretty simple. Sometimes the notation can throw some students off. So let's look at some example problems. In order to evaluate a function, we'll substitute the given value for the variable and simplify using the order of operations. So let's look at this first problem. If f of x, which is how you read it, f of x equals 5x squared minus 8x plus 4, what will the following equal? So if this is our function that we're looking at, f of x equals this, let's look at a. What is f of 4 going to equal? Well, what are they asking us to do? They're simply saying, and you can probably intuitively figure this out, they're simply saying if I put a 4 in place of my x, what's my answer going to be? What is f of x? What is the y value? What's the output going to be? So when 4 is in place of x, well, let's just find out. So we're going to rewrite this squared and a 4 there plus 4. So look, all we did was replace our x's with 4's. Now let's solve it. 4 squared is 16. 16 times 5 is 80. 80 minus 32 and plus 4. So what's 80 minus 32? That's 48. 48 plus 4 is 52. So f of 4 is equal to 52, which is what I'm saying is when x is 4, this function is going to be equal to 52. I'm going to check my math again, see if that, yeah, that looks good. All right, so what about f of negative 2? You get the idea. See if you can do this next two on your own, especially this last one's pretty easy, right? 0. All right, so let me write this one, and hopefully you've tried it yourself and paused it and worked through it, because that's the best way to learn through these guys. 8 times negative 2 plus 4. Negative 2 squared is 4, so it's going to give me my 16. I'm sorry, the 4 again. 4 times 5 is 20. This is negative times the negative, gives me a positive 16 plus 4. So add it all together, 20 plus, or 16 plus 4 is 20. So now I got 20 plus 20 is 40. So in other words, f of negative 2 is equal to 40. What about 0? What if I put a 0 here? Well, that's simple. X, I'm sorry, not x, but 0 squared minus 8 times 0 plus 4. So 0 squared is 0. 0 times 5 is 0. So that's 0. This is 0, and I just have 4. So f of 0 is going to equal 4. Now remember those answers, 52, 40, and 4. Let me rewrite this because I want to show you can actually do this on your calculator, because all you're doing is substituting and solving, and your calculator can do that work for you. So let's go to our calculator, and I'm going to see if I can remember what those answers are. Was it 52? I think we said 40 and 4. So let's put in the calculator and see if we get the same thing. So I'm going to roll over here to my calculator, and you can do this in the calculator itself and solve it, but to me it's more fun to use a graph, and I'm going to show you why here in a second. So I'm going to put this equation in. 5 All right, got my 5x squared minus 8x. I'm just going to put the function in as it is, and you'll see why here in a second, plus 4. Now, by doing that, and I'm going to press enter, it's going to give me this graph. I want to know what y is going to equal when I put a 4 in there, a negative 2, and a 0. Now, the reason I love putting in the graph is because it's easy to check without me retyping everything to solve it. Because if I had gone to calculator, I would have had to type this in each time, plugging in 4, negative 2, and 0. Actually, you could just copy and paste your answer. I don't know if you knew you could do that. So once you place it in, you can actually use the calculator, press Control C, and it'll copy and paste it again and change those numbers. But I just think it's more fun on the calculator itself. Did it just erase my answers? Oh no, let me put that back up here. All right, so now I have my graph in here. I want to figure out what is the value at x equals 4. Now you can kind of trace it if you want to, but one of the cool things you could do is go to trace, graph trace, and when I click on graph trace, you could use your cursor and follow along until you see right down here a x value of 4. And notice that it skipped right between 3.9 and 4. You're like, oh my goodness. So what's another way we could do it? We could pull up a table if we wanted to. I could push Control T and just look down at 4 and see that it's 52. Yay, we did that correctly. And I could scroll up to see -2 was 40 and 0 is 4. All my answers are right there in front of me. So cool, so sweet. Now, again, graph trace, if you're in graph trace, let me make sure I'm in there. Graph trace, you could literally just type in your number also. So I'm gonna go here and just press, watch this. I'm gonna press 4, and it's gonna assume that you're asking for x equal 4, in which I am. And I'm gonna press enter, and it'll take me straight there at 52. And if I type in -2, it'll do it again. So at -2 is 40, and again at 0. How cool is that? How much time does that save? And how less likely it is that you're going to make a mistake? The only mistake you're going to make is if you put the equation in wrong. But other than that, the calculator does the work for you. So I just wanted to show you that cool feature before moving forward, that you can check these in your calculator. All right, let's go back to our problems, because a lot of them we don't need to because the problems are so simple. All right, we got a polynomial here that gives the height of a football in t seconds after it's dropped from a 250-foot tall building. Find the height after t equals 2 seconds. So this is actually a good one to put in the calculator because we got some bigger numbers that we're going to probably want to check anyway. So I'm going to go back to my calculator and do that. All right, so you see how I put this in, -16x squared plus 250. No, I'm not going to put a t in there. Why? Because the calculator doesn't know what you're talking about when it says t. It understands x and y, but we understand that the t is in place of the x. So please put an x here where it says to do so. So this f1 of x is our y, or f of x. This is just saying this is 1 for my first graph. So when I press enter, it's going to graph this. It doesn't matter how I look. I'm only interested in what? Where this height is after t equals 2 seconds, or in other words, where x is equal to 2. So use one of the methods we just talked about to figure that out. So I'm going to say graph trace, right? So if I do trace and I just press 2, and there it is, 186 feet. Now you could have used a table. I'm gonna press Control T or Control T on the calculator here, and I go to 2, and again it's 186. So I'm confirming it all over the place. It's clear. I make sure I put the function in correctly, and I know that I have the right answer. So I'm gonna write in here, just to make this official, 186 feet high. And I could be more specific after 2 seconds. And that's it. That's all we need to do in order to work that problem. So let's go to our next problem and see if we can work that quickly as well. I'm going to keep my calculator out and move through it this way. All right, so the polynomial 6x squared plus 15xy gives the cost in dollars of producing a rectangular container whose top and bottom are squares with side x feet and size height y feet. Now, this talking of a rectangle and stuff makes me want to draw a rectangle, and I hope it does for you, because that's what's going to make this a lot easier. So I'm going to see if I can draw a rectangle as best I can. Doesn't have to be perfect, it just needs to give me the idea, right? So here's 2 parallel lines. Connect those parallel lines. There's my rectangle. All right, now I'm going to polynomial gives the cost in dollars of producing a rectangle container whose top are squares with x feet, size and height of y. Find the cost of producing a box with x equals 4 and y equals 6. Alright, so I just realized I'm drawing all this stuff, and all I need to do actually is plug in, this is not even necessary, but I just like to draw that anytime I see that, is plug in my x and my y in this function. So instead of having 6x squared plus 15xy, we're going to plug in our x and y in this function. So 6, for my x I have 4 squared, plus 15, for my x I have 4, and my y is 6. And we're just gonna do the math on this one. Since I have my calculator, I'm definitely using my calculator for this because that's what calculators are good for. So I'm going to go to my calculator screen and just put the problem in. So we have 6, 4 squared plus 15 times 4. And the calculator does PEMDAS, so it should know to do the multiplication first. But to make sure, I'm going to put a parentheses around this whole thing to say, please make sure you do this all together. Double check to see if I put everything in there correctly, and it looks like I did. I'm going to put the parentheses around here just to make sure it does all this together as well. So please do that first. What I'm telling the calculator is make sure you do this part first, then add. So let's press enter and see what we get. 456. And if you wanted to, you could do it by hand to double check. And if I were taking this test, I would just actually just go ahead and write this out. That's going to be 60, right? Yeah, 60 times 6. And 6, that's 360. Plus 16 times 6. What's 16 times 6? So that part I can do in the calculator. 16 times 6 is 96. And I'll just check it. Just 96 plus 360. So there's another way I can check it. It's worth the 30 seconds it took, or less, probably less than that, to just redo it. I like to check everything at least 2 ways. Work it one way and find another way to check it. All right, so how does this show up on the STAR test? What does it look like when we have the STAR test out? So let's look at how it shows up then. So a few years ago, here's one of the problems that you could have gotten. If f of x is x minus 3 squared plus 4 and g of x is x cubed plus 2, which statement is true? F minus f negative 2 is equal to g negative 3. Now, here's what they're asking. If you put a negative 2 in place of this and solve it, will you get the same answer as if you put negative 3 here and solved it? Will they both come out the same answer? Be honest, before I start doing all this, I'm going to use my calculator. I'm going to put both equations in the calculator and punch in those values each time to see what's true. So let's see if we can work it that way. I'm going to put this in x minus 3 for my first one. All right, so I got my x minus 3 squared in, and I'm going to do plus 4. So that's one of my equations. And I want to put the other one in. And this is so sweet. I feel like it's cheating sometimes, but we're allowed to use a calculator. But if you know how to use it, it's going to feel like cheating. It's like this is too easy. So hopefully this works out the way I'm wanting it to. So let's see. So we got x cubed. I'll put this little caret cubed. I'll push my arrow to come down and plus 2. All right, so I got these two equations, and they want to know where they're equal. Oh my goodness, I can actually see where they're equal. Look at this. So they're equal right here. So at this point right there. All right, so we got these showing us equal right here. Now, if we were doing some kind of system, that would help us, but they have different values in here. So the best way probably to check this, well, one way you could do is find where it's negative 2 for this graph. Look at the answer, write it down. Find where it's negative 3 for this blue graph. The red graph for the other graph, and see if they're equal. Now you can do this easily by pulling up a table. So now I can see, let me pull this table out a little bit. So now I can see what's going on. So I can say when x is negative 2 for this first function. So let's go to negative 2. What's the y value? Well, that's going to be 29. I'm going to write that down. So it's a lot easier than me trying to do the calculations. So I can say this is 29. And what is g of negative 3? This x cubed plus 3 when it's negative 3. So I'm going to scroll up here. So at negative 3, that's a negative 25. So this is a negative 25. Those obviously don't equal. So we only got 3 more to check. But look how much more comfortable it is than plugging this in each time. That's 6 different calculations you're making, increasing your chances of mistakes. So now we've canceled f out. Let's go to g. So when f of 0 So f of 0 is 13. Let me go to 0 and -1. Yeah, there we go. So f of 0 is 13. G of -1 is 1. Those don't equal. So we see that right there, right? 0, when x is 0, this is 13. When it's -1, this one's 1. These do not equal, so that's not going to work. F of 8. Let's go to f of 8. So I'm going to slide down to f of 8. We got 8 and 3. So let me start with 3 then. So we got 3. At 3, we have this g of 3 equaling 29. So I'm going to write 29 there. And you could probably remember it, but it's nice just to kind of jot it down. That's all the work we're doing anyway. And I'm going to go down to 8. And look at that. Look at that. So we got 29 here. And there's our answer. Now, just for kicks and giggles, I'm going to go ahead and look at 2 and 1 as well. So here's 2 and 1. So when f of 2, here we have 5. And for g of 1 is 3. So that's obviously not going to be right. So our only answer is here. Now, the great thing about using a calculator is two things. One, it saves you a ton of time of doing the calculations, and it saves you a lot less mistakes, right? Because you could have made a lot of mistakes plugging those in, or just been frustrated with the process. Plus, it looks like it's toward the end of the test when that problem came up. So let's go to our next problem. All right, for our next problem, if f of x equals 2/3 x squared plus 8x, what's the value of f of 6? So really all they're asking us to place the 6 in place of the x's and solve it. Now you could put this in your calculator if you want to, but this seems pretty simple to solve by hand. So I'm just going to try to set this up by hand. Let's see, we got 6 squared plus 8 times 6. 6 squared is 36, so 2/3 times 36. That seems complicated, but this is actually not too bad. 36 divided by 3 is 12. 12 times 2 is 24. 24 plus 48 is 72. That looks right. 6, 7, 72. Now we could check this at the calculator if you wanted to. So let's do it. You can use the calculator portion if you wanted to. I just like using the graph because I could put multiple things in there. So I'm going to set this up in our calculator. 2/3 x squared. And I'm going to eventually evaluate for that like we've been doing. So that's 8x. Make sure I got that in correctly. So when you put it in the calculator, the main thing you can mess up on is just putting it in correctly. So I'm looking to make sure it's in correctly. Press enter. Now I'm going to look for what's the value when x is 6. I can pull up a table, which is probably the cleanest way. So I'll just pull up a table and I go down to 6, and sure enough, it's 72. And there we go. Simple as that. Same thing for this one, but this one seems so simple that I don't need a calculator. So let's try it. If I put 6, 1 minus a -8, so that's where it would get a lot of people, is in place of that x, you need to put a -8, 1 minus that -8, and solve it here. So I'm going to do my parentheses first. This minus a negative turns into a plus, so that's 1 plus 8, which is 9. So this ends up being 6 times 9, which is 54. All right, let's go to our next problem. So make sure you put 54 in the answer document correctly. You don't want to miss that. Actually, and you could check this with your calculator. I'm not going to. It just seems pretty straightforward, but you could check it if you wanted to do that. All right, so here's one that seems pretty complicated. For the function w, w of 9 equals -7, w of -7 equals 9. If y equals w of x, what's the value of y when x equals -7? What are they talking about? So what I would encourage you to do with something like this is outline a table. So we have, let's say, okay, w and x. So let's use w and x. So we have x, and instead of y, they're calling it w. So some function w. So when I put in a 9, what do we get? -7. And when we put a -7 in, what do we get? We get a 9. And what they're asking is, what's the value of y, or our w, right? So this whole thing, what's the value of y when x equals -7? So x equals negative 7 is just going to be 9. So once you write it out like that and see that they're just giving us points, you'll see clearly that it's just going to be 9. So I mean, I don't know how else to do that when it's so straightforward. I feel like there's something else I need to do. So did we cover everything? Did we cover our objectives? Absolutely. We talked about evaluating functions, expressing those functions in function notation, given one or more elements in their domains. Guys, good job. It's pretty straightforward. The function notation itself can look confusing, but now you can see it's simply a matter of plugging in that x value into that function and solving it. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.